Hello, everybody. I told you guys I would make a video going over our homework, and I feel as though if we take this extra time out of class, maybe this first week or so, we'll set ourselves up for success when it comes time for our final exam and just moving along anyway on pacing. So your homework's on page 369. It starts with number 1. So I already kind of started number 1, so I'm just going to walk through it real quick. We did a number 1 in class, a lot of us did. So number 1 says 25 to the power of 2x plus 3 equals 25 to the power of 5x minus 9. Well, 25 equals 25. They're the same base. So we know that. We can set that to each other, and we're good right there. But it asks us to solve for x. So because this number, this total number right here, equals this number, we can set our exponents equal to each other. So we have 2x plus 3 equals 5x minus 9. Well, anything I do to one side to get my x alone, I'll do to the other. So I chose to add 9 here and add 9 here. And I subtracted 2x here and subtracted 2x here because we want to get x on one side and our constants on another. This left me with 12 equals 3x. And I divided the 3x is the same as 3 times x. So the opposite of 3 times x is division. So I'm going to divide it by 3 and then divide 12 by 3. So x equals 4. Now the book tells us that they're equal to each other, but we want to get into the habit of checking our work, verifying that our answers are valid. So we can just go 2 times 4 plus 3 equals 5 times 4 minus 9. 2 times 4 is 8 plus 3. 5 times 4 is 20 minus 9. Both equal 11. My answer is valid. I promise I know how to spell. All right, the next one's number 3. So on number 3, we have 4x to the power of x minus 5 equals 16 to the power of 2x minus 31. These aren't the same bases. However, 2 can be a base of each of these numbers. So when we look, we have 2 to the second and 2 to the fourth. So what we're going to do now, our bases are now the same. So we're going to set our exponents now equal to each other. So the way this would look if we rewrote the whole thing would be 2 to the power of 2, parentheses, x minus 5, equals 2 to the power of 4, parentheses, 2x minus 31. Okay, so now I'm going to do 2x minus 5 equals 4, 2x minus 31. Distribute, 2 times x is 2x minus 10. 4 times 2x is 8x minus, let me do this math, 4. I forgot my calculator at school. 31 times 4 is 124. So now I'm going to do the same thing I did on number 1 to get my x's alone. So I'm going to add 10. So I have 2x equals 8x minus 114. Subtract 8x from here, 8x from here. So I have negative 6x equals negative 114. And 114 divided by 6, I think equals 19. We'll let the computer catch up on itself. So we're going to divide by negative 6, divide by negative 6, and yes, x equals 19. Again, a good habit to get into is to put 19 back into here and solve the equation with the 19 as an x, like we did here. For time's sake, I'm just going to tell you that x does equal 19, and your answer is valid. All right, number 7 says, Bianca invested $5,000 in an account that pays 5% annual interest. So remember, when we get the word problems, what I said was to write P, we got 5,000. R says 5%. And it's saying it pays. Remember, pay is a key word for compound interest formula. We want to look for grows, multiplies, pays, earns. Any positive money term, we'll use our compound interest formula of A equals P times 1 plus the rate over the number of times it compounds to the power of NT. So what it says, write a function that represents the value in Bianca's account Y. So in this, it wants A to be Y. And after time, X years, it wants this to be X. It wants our T to be X. So we'll write Y equals, well, it gives us the principal of 5,000. So 5,000, the 1 is always given. But we have to do something to our rate. Remember, we have to move our decimals point always over 2 to the left because our rate has to be entered as a decimal. So I have 0.05. Now it says annually, and that is a key word for our interest compounds monthly. So when we get an annual interest rate means we are paid monthly. So the number that we're going to do, remember n equals the number of times it compounds, will be 12. Now this n right here is the same as this n, as the same as this. So we have 12 and then x. Oh, I almost wrote t. What it wants us to do is x. 12x. So this is what your formula should look like for 3a. Now, on B, it says how many years, so our T is our question mark, right? How many years will it take for her account to have $25,000? Well, A is what we normally solve if we were to find it with time. So what we have here is A equals $25,000. She said, I want to put $5,000 in the bank account and I don't want to pull it out again until it equals $25,000. How many years will it take for it to reach $25,000? So the way that formula looks is 25,000, because we already got the A, equals 5,000 times 1 plus 0.05 over 12 to 12t. We're solving for t, okay? So we want to divide it by 5,000. Divide both sides by 5,000 first. So we have 5 equals 1 plus 0.05 over 12 to the 12t power. Okay. Let me get my notes, 1 second. So we're going to put this in our calculator, the middle portion. And once we put this is 5 equals 1.004 to the 12t. Okay, anytime that we're going to solve for an exponent, this is our exponent, and it's the variable, we have to do what's called natural log. Okay? Our calculator does this for us instantly. There's really no hand math that's worth it, especially at your level. On the calculator, the button is LN, and it is, I think, 2 or 3 above the on button on the left, bottom left. So now, our natural log rule states that if we have the ln of a to the b power, this equals the same as b times ln of a. So what I have here is I have to do the natural log of this. So I'm going to, of this whole thing, sorry, this. This is my A, and this is my B. It's weird looking at it through the camera. Okay. So what I have is, if I do the natural log on this side, anything I do on this side, I have to do to the other. So I rewrite it, ln of 5 equals the natural log 1.004 to 12t. But remember my natural logarithm rule. So now I have the natural log of 5 equals 12t times 1.004. Oh no, not 12t. Equals ln of 12t, 1.004. So now I can divide my 12 and my 1.004 off of this all at once. And that's what I'm going to do to leave my t, because we're trying to solve for t. Same as when we're what I call undressing x, we're undressing our t, right? So we have 12 times 1.004, because these are like 3 things being multiplied together. And then we'll divide our natural log of 12 times 1.004 on the other side. Excuse me, 1 second. Forgot my ln because I wrote it so tiny. 12 ln of 1.004. 12 ln of 1.004. There we go. There's correct now. So this now equals the natural log of 5 over 12, the natural log of 1.004 equals t. Okay? So the natural log of 5, when I put it in my calculator, I hit ln and put 5. That equals 1.6094. And then when I put in the natural log of 1.004, I end up with 0.003998 times 12. 12 times that equals 0.047976. And I have 1.6094 over 0.047976. Now I just solved that, because remember we're still t equals. So t equals, when I put that on my calculator, approximately, we're going to do the squiggly lines because log is approximate, not exact, 33.54. It will take Bianca's banker 5 seconds to figure this out, but then it will take her bank account 33.54 years to reach $25,000. All right, that one was a little crazy. Let's get to the next crazy one. We love crazy. So Ahmed's consulting firm, we're number 9, began with 23 clients. So RP equals 23. The number of clients decreases at a rate of 0.5%. So listen, decrease. Now we have loss, pay or spends, loses, decreases, decays. We are going to use our depreciation formula of A equals P times 1 minus R to the T. Okay. Now we have A, or we know P, that's 23, times 1 minus, remember our rate, we have to go 1, 2, so we have 0.005 to the T. There's our formula. So our function, but they want it in Y equals 23, 1 minus 0.005 to the X. That's what the book is asking for. They want our Y to be our population, or not, sorry, our Y to be the clients, and X to be the number of years. We're just rewriting it. We're appeasing the authors of this book. So it wants to know how many years will it take for his consulting firm to have only 15 clients. So, well, it gives us that A equals 15 now, just like on Bianca's, it gives us the final. So we'll rewrite it, 15 equals 23 times 1 minus 0.005 to the t. You with me? Remember, he's losing clients. So what we have here, we're going to divide 23 off of this, because we are trying to get this t alone. So this says 15 divided by 23, and I'm going to simplify this while I do this division. So remember, these are canceling out. The next number that I write on the right side will be the 1 minus 0.005 to the t. So 15 divided by 23 is 0.6522, which equals 0.995 to the t. Okay? So remember now, anytime we're trying to solve for this, we do the natural log. This one's a little bit more simpler because the depreciation formula is simpler to be appreciated. So we're going to do the natural log on both sides. Natural log on both sides. So remember, in our log form, when we have the log of AB, it equals log of A to B equals B times the log of A, but we're doing natural log of AB equals B times the natural log of A. Just remember that one. That's coming up next unit. All right. So because of that, I now have T times that. Okay? Now I'm going to divide off the natural log of 0.995. Divide this side by the natural log of 0.995. And that's going to give me negative, I'm putting my calculator, just typing that in my calculator, hitting enter. Then I'm going to write it down first, 0.4271. And then I put this in the calculator, and I'm ending up with negative 0.005012 equals t. Okay? When I divide these two things together in my calculator, I get 85.25 approximate years. So it will take him 85.25 years to go from 23 current employees to 15. Right? All right. So let's get to some of the fun ones where we learn out. I think this name on number 11 is pronounced Siobhan. So we have Siobhan depositing $1,200. So P equals 1,200. So right now we just know P. We're looking for the keywords. It pays. See, there's another keyword. It's paying. So now we're going to use our compound interest formula. Okay? A 5.2% rate. So we move our decimal to the left twice. So we have 0.052 will be our rate. And it says it compounds monthly, so our number equals 12. What will the balance be after 4 years? Well, look, it gives us T. This might be the easiest one that we do on this homework. So we have A, that's what we're looking for, after 4 years, equals 1,200 times 1 plus 0.052 over 12 times 12 times 4. Okay, and I forgot my calculator, so I'm going to set this down real quick, type that into my calculator, and then move on from there. 0.052 over 12 to the power of 48. All right, so we're just solving it out. And it wants us to know to solve it to the nearest cent because money is real, right? So we have A equals $1,479. and 60 cents approximately. So all I did was you put this in the calculator first, multiply it, get your answer. All right. Number 13. Maya deposits $5,000 into a checking account, and it pays 0.75% annually. So the number equals 12 because the interest is compounded monthly. So our rate here, when we move this over twice, now equals 0.0075. And our number is 12. What will it be after 8 years? So because this t equals 8. So we're just going to do the same thing. A equals 5,000 times 1 plus 0.0075 over 12 to 12 times 8. Let me type that in my calculator. All right. Like I said, you can just type that straight in the calculator. When you type it into the calculator, your A will approximately equal $5,302.18 after 8 years. So she made $302.18 after 18 years, or 8 years. It may not seem like a lot, but if you put $5,000 under your bed, will it pay you $300? No. So if you have the luxury and the freedom, the adult lesson of the day, if you have the luxury and the freedom to put $5,000 into a savings account, this is a very low paying savings account. Don't ever get one this low. Anyway, after 8 years, you will have earned $302.18. All right, the next one that we have is number 43. All right, Ingrid and Alberto each opened a business in 2010. Ingrid started with 2 employees, and in 2013, she had 50 employees. Alberto began with 32 employees, and in 2017, he had 310 employees. So it's 2010, each company has experienced growth. Okay, that's our key word. Write an exponential equation representing the growth for each business. So we're going to use this formula. So we have Ingrid first. And we have to figure out what the growth rate is. So the first thing is in 2010, at year 0, okay, Ingrid had how many employees? She had 2. Okay? That's what we're going to start with right here. So we have y equals 2. Nope. Hold on 1 second. Erase that. We have to first find y equals AB to the t. Okay, so Ingrid, she started with 2 employees, okay? We're trying to figure out the growth rate, or the base, and our growth rate at year 0 is times b to the 0. Remember earlier today, depending on your class, I said any exponent that's 0, b to the 0 equals 1. So we have 2 equals 1a, so a equals 2. So now we've gotten the first portion. It wants to now know in 2013, because now we're trying to figure out the growth rate. So in 2013, she had 50 employees. So the time here, we go 2013 minus 2010 equals 3. Okay, so now we have 50 equals a, or equals 2, because we got our a, b to the 3. So now we divide by 2. 25 equals b to the 3rd. Now we cube root it to get that 3rd off of it, okay? but that ends up equaling B equals 2.924. So now we could rewrite our equation. Y equals, sorry, we're doing the exponential function. Y equals 2 times 2.924 to the t. So we figured out the rate of change between 2 and 50 over 3 years. That's what this is, the rate of change. Okay, so Alberto. And Alberto had 32 employees in 2010. So 32 employees, we know A equals 32 starting year. Okay, so we're gonna go back. And it says in 2017, now he had 310 employees. So we have 310 equals 32, B, and then the difference between 2017 and 2010 is 7, B to the 7th. Divide by 32, and we end up with 9.6875 equals B to the 7th. Well, now we have to 7 root everything. Okay? So this ends up as being 1.316. Now to write our equation for Alberto, we have Y equals 32, our base rate, times our rate of change, our growth rate, 1.316 to T. Alberto. Ingrid. Okay, so that's the long answer for A. Now it wants us to know, using these formulas, what's the rate for 2015? Well, 2015 minus 2010 is 5. So now we go Y equals 2 times 2.924 to the 5th for Ingrid. And that ends up being approximately 427 employees for Ingrid. Okay. For Alberto, we do Y equals 32 times 1.316 to the 5th. Y equals 126 employees. There's our answer for B. Now C, it says, there's B, sorry. C, it says, is it reasonable to expect that a business will continue to experience exponential growth? Well, we know that if we put an exponential growth function into a calculator, it sometimes has a rapid rate of change, but it always levels off at what? It levels off at our horizontal asymptote. So there is a ceiling. There is a ceiling to growth, right? If we think about reaching the amount of people, you have something cool to tell everybody. Well, you tell one person, then they tell 2 people, then each of them tell 2. Eventually, you're going to run out of people to tell. Everyone in the world would have heard if it goes enough and you have enough time. So that is why we have that horizontal asymptote, which is where our line will never cross. That is the point at which you will never grow past. So that's what we're seeing here. Will the business continue to experience exponential growth for a little bit, and then it will stop. It'll level off. It's important that we remember that. So now we have a decay formula. Number 55 was assigned because it's something that we may not have a ton of time to be on in class, but it's a great homework question. So we're going to talk about exponential decay. So that formula is the concentration at the time of equals the initial concentration times Euler's number minus, or to the power of negative K over T. K is the decay constant and T is the time. So the first thing we have to do is find K. So we know that after 2 hours, our T equals 2. The concentration is 1.5 milligrams. okay? So now it decays at a rate, or the concentration is 3. So we have 1.5 equals the original initial concentration of 3.0 times Euler's number, and the time that we have, the constant is -2 or time is 2 to K. We're trying to figure out the decay constant. Can we give this medicine at 3 p.m. and it still be effective? It hasn't reached its ineffective level of 0.6 milligrams. A lot of you are going into medicine. This is super important. So now we want to divide both sides by 3. So 1.5 divided by 3 equals 0.5. So we have 0.5 equals E, Euler's number, to -2K. Remember, we're trying to find the decay constant to make sure that we can do this. We're solving for any unknown variable. We have to take the natural log of both sides. Well, the natural log of this is 1, right? So if I did the natural log of E times 2K, which was my log rule, I would have 1 times 2K, -2K. So I have the natural log of 0.5 equals -2K. Now I need to get K off this, so I would divide both by K, divide by 2. I don't know why I chose K. -2, -2. So now I have K, equals negative natural log of 0.5 over 2. So that is what K equals. That is our K rate. So now it wants to know from 10 a.m. to 3 p.m. And this is an exact number. I have to tell you, in medicine, it's exact. So you would stop here. Okay, if you were to solve for a number, that would be the approximate. Well, we have to think, is life or death, right? Medicine is life or death. If we were to approximate a number and that medicine concentration dropped below 0.6 in someone's body because we were rounding, they could die. So in life or death situations, we want to use the exact, precise answer. That is this, okay? So now it says 5 years. So we have the C of 5. I'll come back to the camera in a second. Equals 3.0 E to -5 K, because now our decay factor has changed. We're now doing, our time has changed. We now have 5 hours. So same way that we did up here, divide by 3. Divide by 3. I gotta put this in my calculator. Okay. So if we got this number out, we would put it here, right? So this would be -5 times the natural log of 0.5 over 2 for our exponent. So we have, concentration at 5 hours equals 3.0 Euler at -1.733. We're taking this out of approximate or out of exact to approximate because we have to solve for a number. So ignore this. I can do this math. I can type this literally in my calculator. 3e to the -1.733. Just like that in the calculator. So the concentration of E. So then we have E to here equals 3 times 0.176. Concentration at 5 hours is approximately 0.53 mg over milliliters. So it says it cannot really go below 0.6. So would they be able to give that dose at 3? And the answer is no. It would need to be sooner than 3. So anyway, that is our homework. That took 35 minutes. I know you're smarter than that than I am at all times. You guys are so intelligent. So I don't know if it will take you 35 minutes, but if you walk step by step, 35 minutes it is. See you guys tomorrow.